Welcome. In this video, we're going to begin talking about polar coordinates and graphing points in polar coordinates. And moving forward, we'll talk about converting between polar and rectangular or Cartesian coordinates. So at this point, most of us should be very familiar graphing with X and Y ordered pairs on a rectangular or what we say Cartesian plane. So instead of X and Y with polar coordinates, we talk about R and theta. Just like X, Y is an ordered pair, polar coordinates are an ordered pair as well. R comes first, theta comes second. So polar coordinates, generally we draw them on a polar graph. As we think about identifying some of these attributes of polar coordinates, what we're going to think about here is we have a pole. This is my pole, is the origin. Okay, so the origin's my pole. And the positive half of the x-axis, this is my polar axis. This is always where we're going to start, on the positive x-axis. As we start thinking about polar coordinates, they have to deal with an angle measure, theta. Theta is always going to be a positive rotation, just the way we think about with a unit circle, right? So positive counterclockwise off that polar axis. And we have a distance out, a measured distance out. That is R, my radius. And that R radius, that takes us to a point at the end, R units out, so this measures R, and then an angle rotation of theta. So R theta is my point. So what we can think of is this point, a point, R comma theta, can be plotted in the directed rotation. So we have a direction. We have to go the way that theta is describing. So a directed rotation theta from the polar axis to the angle theta, and then we have a directed distance, and that is R. So that's the distance out on that radius from the pole, the origin, to my point, R theta. To plot points on a polar graph, the first thing we will do will be to locate that directed angle theta. So we'll travel on our unit circle to theta. At that point, once we've discovered where we're going to be drawing our radius on what line, we're going to move that distance, which is directed. And directed just means we can have a positive or a negative radius. So we're going to move R from the pole, which means the origin. Now, if R is positive, we would move out along the ray OP formed by that directed angle where we just stopped. But if it's negative, we're going to move in the opposite direction. So an opposite direction would be plus 180 degrees or plus pi. We'll be looking at that angle measure. So let's try and see this in real life. Let's look at plotting these points on the polar graph. Now remember, each of these ordered pairs, we are presented with an R first and then a theta. So for A, we need to go to 30 degrees. That means we're traveling off this positive x-axis and we're going to rotate up 30 degrees. So here's my 30-degree line. Now, where is that point? That point is 1, 2, 3, 4 rings out. So this point, this big dot that I'm drawing right here, that dot alone is what represents point A. So this point A, we traveled up 30 degrees. On that 30-degree line, we counted out 1, 2, 3, 4. 4 rings. Let's try that again. B, we have 3, 150 degrees. So I come over here and I go, okay, well, here's my 150 degree line. And I'm going to count out 3 rings. 1, 2, 3. So this point, 1, 2, 3 rings, that is how I got to my solution for point B. All right, let's mix it up. C, we're dealing with -2 and 7 pi over 6. 7 pi over 6. Where does that end up? And if we have a hard time thinking about radians, we can always convert to degrees by multiplying by 180 over pi. But this is the same as -2, 7 pi over 6 is 210 degrees. All right, so that means I'm going to come over here to 210 degrees where my 7 pi over 6 would be. But I'm going to go, instead of coming out along 210, 2 spaces, I'm going to go in the opposite direction. And what is opposite 210? That would be 30 degrees. So we could also think about this as 2, comma, if I take 180 away from 210, that leaves me with 30 degrees. So point C is located right here on my 30 degree line, which is directly opposite my 210 degree line. And I traveled out, since we had -2 at 210, I traveled out 2 in the 30 degree direction. Let's try that again. So for D, we have 300 degrees, -6. Well, if I want to turn that to a positive radius, then I will subtract 180 degrees, which gives me 120 degrees. So we go to 120 degrees over here, and we're going to count out 6 rings. So we've got 1, 2, 3, 4, 5, 6. So there is point D. And my last point we'll do here, E, we have it negative and a negative radian measure. So this is the same as -5 and -45 degrees. Or -45 degrees, -45 degrees comes down this way, and we have positive 315 degrees. Right? 315 degrees is my 45-degree angle in quadrant 4. Now, if I want to turn that positive, I will add or subtract 180 degrees. If I subtract 180 degrees, that takes me to 135 degrees. So I'm counting out 5 rings on the 135 degree line. 1, 2, 3, 4, 5 is right there. Now, you aren't going to have to specifically be plotting polar points on your tests or anything in this class, but we do want a good understanding of it because we see a little bit of it at calculus, especially once we get to calculus 3. So we want to have seen it once so that it looks familiar to us a couple classes down the road. But really, I think that's the earliest we use polar coordinates pretty significantly again. All right, so I hope that makes sense to you. That's it for right now. Next, we're going to talk about converting between rectangular and polar coordinates. And we have some relationships that we like to use. So I'll see you in a couple seconds in the next video.